Feature definitions are a great way of customizing this software to your needs. Basically, they are command sequences, or little macros, that encapsulate a more complex functionality. You can write your own functions in a script-like environment. In particular, the so-called meta surface is also based on curves that are provided by feature definitions. In the following steps, we will create a first feature with some scalar input and output data. New definitions are automatically put into a separate tree node. Set a type name for your definition. Specify input data for which you have to choose what type of data is needed. Specify variable names for your inputs. Now, let's define the simple sum of the two input values. We apply the changes, and create a feature object that is then based on our new definition. Set an object name, as well as some values for the input. The sum is shown in the tree as a subnode of our feature. Values or objects in feature functions are so-called attributes that can be accessed from outside. Let's create another attribute and apply these changes to our existing feature object. The new attribute length is now also part of our object in the tree. These feature attributes can now be accessed and utilized in our project. For a quick example, we create a line that will be dependent on our length value. Just drag and drop the value into the editor of the other object in order to connect both. Now when you change the feature input values, the line will also change. We highly recommend to use auto-completion when you set up your own feature definitions. This makes it very efficient and you do not have to memorize all available commands. In this example, a radius value is provided as input and we want to set this value at a circle object. First, we create the circle. In the next step, we want to call the set function for the radius attribute of the circle. We use control space for auto-completion of the name and commands. Once again, let's have a quick look at the result. The circle is available as attribute, and can be accessed in the tree. Note also that often objects have some default values, such as the values for the start and end angle. Sometimes it can be helpful to customize the graphical user interface of a specific feature definition for more usability. The user is free to define own categories and labels. Typically, set and get commands of specific geometry types are used in feature definitions. Click on the type icon of an object so that the type documentation is shown. The properties of this specific type are shown, where also commands of parent types can be used due to the hierarchy. Type functions are also available, and they can be additionally utilized in feature definitions. Global commands are not type-specific, and they are also available for usage within feature definitions. For instance, use these commands for reading and writing files, for access to project and design directories, as well as for mathematical expressions. The commands are listed with their return values and their input arguments. There's also a convenient way of putting more complex functionality into a feature definition with a single click. In this quick example, we want to create a custom curve type. Only the star tangent angle and the curve's integral area shall be the user input. Instead of typing a feature definition, we first create everything interactively. For the scalar input arguments of the upcoming feature, we introduce parameters. Now, we select everything that will be part of our new feature definition. We do not select the parameters since we want these values to be input of our definition. Create a feature definition from the selection. The involved commands are automatically generated. Each dependency that cannot be resolved gets detected, and input arguments are set for this missing information. In our case, the parameters were not available during the creation process. We can remove the initial setup, since everything is now encapsulated in a feature definition. The curve can now be controlled by the two inputs. Most of the times, persistent feature objects are created from feature definitions. But you can also run a command sequence of a feature definition once, and all feature attributes are simply put into the tree. Feature definitions can be exported and used in other projects, or they can be shared with colleagues. This feature here creates the remaining blades of a fan, and we want to make it accessible within other fan projects. We can add a descriptive label and even comprehensive documentation. Export the feature definition so that it gets stored, for example, on your hard disk. You can choose to include the directory to be available in the menu of the graphical user interface. The exported definitions of the custom directory are available for other projects. The quickest way to syntax information is by clicking on the type icon of a feature definition. There you find brief examples for object creation and setting, control statements, loops, file input and output handling, etc. In addition, you can also visit our CAESES forum where you find further examples and support from other users. Finally, a brief tutorial guides you through the most important issues of feature definitions, and gives you additional tips and tricks.